So hello everyone, welcome to KubeKode, and today we are going to learn about Apache Kafka, and this will be your video like where you can go from zero to your first topic in Kafka. So we will be having some live demos, and by the end of this video you will know how to install Kafka, how you can create topics, how you can produce and consume messages via both CLI, and we will try a Node.js based application as well. So and you will understand like when and why you should use it. So if we talk about just the introduction of Kafka, here you can see I have created just a blog, and in this blog you can find out all the things which I'm going through in this video. So uh, coming to the introduction, modern apps juggle quick lookups and heavy tasks, right? Like think uploading a video, and for that you are generating some thumbnails, you are scanning the video for content, you are updating the feeds, or you are using some logging as well for analytics, right? So doing all those tasks synchronously means like your users will be there on your for the response only, right? So they will be waiting for you. Right, so you can't risk that, right? And you need something that will work asynchronously to respond to your users. And even in this setup you will risk timeouts, blocked resources. Instead, what you want to say, you just want to say that okay, your job is queued, and check back in a moment, we are working on it, right? So just an example, what I'm saying is, let's say you have a service, right? And a user is uploading some videos, right? So this is a user and he uploaded some videos, right? Now your service is there, which is upload service, where you have uploaded the video. Now their event will be generated, right? So this is a typical client server architecture, if we can say, right? So user has requested, and in request he has sent a video, he uploaded a video, right? And you want to you want to generate some thumbnail for this video, right? Or you want to scan the video for some content, or you want to add the logs as well. You will have to send the video for the logs that this video got uploaded. So you will not do all those things, and after that only you will respond to users, right? You can't do that because there will be request timed out, and user can't wait for that so long, right? So what you will do, you will just say okay, these are some workers, let's say, for you, and you will just say to user okay, your video has been uploaded and your tasks has been started. So we will quickly, once it will be completed, we will give you the thumbnail, right? So we can say like that, right? So you can't make your user wait here, right? So Kafka makes that pattern bulletproof at scale. Actually, we will see how we can make use of Kafka here in this setup. So first of all, uh, before moving ahead, we need to discuss about the synchronous and asynchronous programming and asynchronous processing, you can say. So if we just look at the synchronous call, so in a synchronous interaction, the client sends a request and waits for the server to completely processing before it can continue, right? So what does it mean? In any typical architecture, you have a client and a server, right? So this is a server and you have a client, right? So let's say client is sending a request to the server, and quickly server is responding here. So what is actually going on? So here if you notice, client will send the request, and client will wait for the response until he is getting the response, right? So server will do all the work. uh, let's imagine a simple CRUD operation, right? Let's say client is posting some payload, let's say some name or something, or right, and this server need to update this to a DB, right? And after updating this payload or this data to the DB, the server will respond to the client, okay, your data has been uploaded and thank you so much, right? So this is like user want to create his profile or something, right? Anything. But let's say this task is a little bit complex, and this is actually a tight coupling here, because we are waiting for the DB here, and then we are waiting for the server to respond to us. But let's say here we have a lot of work to do, not only to update to the DB, we have work to, let's say, search this user, is he there inside our DB or not, or let's say we want to have some logging service as well, right? So if we talk about just this architecture only, your client is sending you a payload, let's say to update a user profile or to create a user profile, and you have two things. Server has two things to do. Let's say first to update to the DB, right? And for second, let's say server will be sending this to a logging service where we can analyze the logs and all, right? So you will be responding to your client just after this process will be completed, right? This process, you will not wait for the logging service to be like your logs has been uploaded or has been sent to the logging service or not. You don't need to wait here, right? You just need to send the response back to your client. Okay, your profile has been created in the DB, and that's it, right? Because this is for you, right? This is not for important for the client. So this can be your asynchronous request here, or asynchronous processing, and this is your synchronous call, right? So this is how it works. And this is like asynchronous programming. So if we just dive in more into it, so you can see, for an example, let's say you are ordering something on any e-commerce website. You are a user, right? And this is the ordering service, let's say, and you need to send back to the user. Let's say user has ordered something, ordered item, or something like this event has been generated from here, and here we need to process many things, right? So we will just send a request to the user that okay, your order has been successfully, your item has been successfully ordered, and you will get the notification soon, right? So let's say you want to send a notification to the user. You have to you want to notify that okay, your order ID is this and this and all. So you can do all these things asynchronously. So basically what you are doing here, here you have other services as well. So to these services you are sending as an event, and that event can be like ordered item or something. So here basically we don't directly respond back to, we don't wait for our response back from the workers are basically these services which are working on our event. But instead we will just respond back to the user, okay, your order has been done, and we will notify you soon, right? So like this we can do. So here, just one more thing. If you just go to the blog, you can see in asynchronous programming, our server will send our request to the worker, and it will say to client, okay, your request is in the queue, and it has been started. So just wait for it. You will get your result soon, right? But here the problem is, you can't directly send your event to your worker, right? Let's say this is where message brokers come. Okay, we are just going through that. So user has requested something, and we need to process that request by a worker, right? This is a worker, let's say. And let's say so we will respond back to the user that okay, your request is in the queue, or it has been started by the worker, so you will get notified soon, right? So like that you can do. Or once the worker will complete the request, so worker can say okay, it is done, then maybe server can notify again to the user. Okay, but the problem here is, let's say your server is not working fine, or let's say your worker is not working fine. So what can be the problem? Problem is, if your server goes down, then all the events, these events here on the server, uh, worker will not be able to process because server is not running. So worker will not be getting any events or any jobs to process, right? What if worker goes down? If worker goes down, then server will be sending the events to the worker, but worker will not be able to process it, right? So there we can have some missed problem, we can have some problems, right? Like our data can be missed there. Also, let's say if this server is sending one event to the worker, and this worker actually fails to process that specific message or a specific data or a specific request. So what will happen, it will not retry that, because server directly send that request to the worker, and worker will proceed to process the next request. So what we can do, so we need to decouple this, right? So this is actually, this worker is dependent on server, the server is dependent on worker, right? So we need to decouple this thing. How we can do, we will just remove the worker from here. We don't need to send the data directly to the worker. Instead, in between we will have a message broker. This is a message broker which we will be having in between, and every request that will be coming from the server, it will be storing in a queue kind of, right? So let's say this is first request, second request, third request, then this is the worker here, and this worker will basically pull all these requests or messages and it will process it, right? So this is, if server goes down, even our messages are here, right? If worker goes down, it's fine, our messages will be safe here in this message broker, right? So this is a really good example, and this is how we work with message brokers. So now, why introduce a message broker? We can get retry, dead letter queues, decoupling, load buffering, and these are all those benefits message broker will provide you. So what is a message broker? Is just a middleware between that sits between the part of your system that produce work and the parts that consume it. So instead of coupling your API directly to your workers, you hand off tasks as messages to the broker, and your workers can pull the messages when they are ready, and they can process them, right? So this is how a simple architecture will look like. So in every message broker, the service which is sending the messages or emitting the real-time data, that will be called as a producer, and the services which are consuming those messages or processing those messages, those services will be called as consumer, right? So what are the benefits here? You can read producer versus consumer terminology and all. So there are two types of message brokers. Okay, so one is the message queue and one is the message stream. So message queue is basically one delivery, and our message stream is actually one to many delivery. So if we talk about it, so we have two things, right? One is message queues, one is streams, right? So if we talk about the queues, so in queues, it is actually one delivery. So what does it mean? A queue is like, this is, let's say, your producer, right? And this is producing some data to the message broker. So this is actually a queue. So in the queue, from the name only, you can guess that it is kind of a queue which will be storing your messages in a queue. Like first this producer will send this message, like this is the first message, then this is the second message, this is the third message, and fourth message, like that, right? Now this is our worker, let's say, right? So worker will be pulling these messages from the queue, right? So let's say first it will pull the first message, right? It has pulled the message. Then after processing it, these queues provide some APIs or some methods where your worker, only after processing the message, your worker can delete this message from the queue. Then after deleting, again it will go and it will pick the latest message. So this is how it works. First this one, then this will be deleted, and also you can implement some dead letter queues here as well. So if your worker will not be able to process this message, so this message can be sent to a dead letter queue, right? So dead letter queue is similar to like a backup queue, right? So like this works as a message queue. If we talk about message streams, but here if you see, this is 101. So there's one producer and one worker only, or you can say it is a consumer, right? So this is basically consuming the messages, and it is deleting the messages as well. But what if you have a lot of consumers, not only one consumer? What you will do, right? So there you will be using message streams, not message queues. Let's say this is the producer, right? It is emitting the messages into a message stream, right? This is a message stream, and in message streams you can say like in stream it will not messages will not be stored like uh, in a queue, right? Instead this will be storing all the messages in kind of a list, or you can say, right? So let's say this is the first message, second, third, fourth, five, six. Okay, so you can have many consumers here. Let's say I have two consumers here. This is consumer 1, this is consumer 2. So these consumers will be basically pulling those messages, but this will not pull the latest message. What they will do, because let's say if you talk about the previous architecture which we were discussing about message queues, if it will pick up first message, process it, then deletes it. But let's say our consumer one is like was not even free at that time, and he this consumer has not processed the first message, then what will happen? Then our message will be missed, right? So in message streams, messages will not be deleted. No deletion here, auto deletion, right? Instead, these consumers iterate the whole stream, and after iterating they process each message, and similar to the similarly this consumer 1 will also process all the messages, and consumer 2 will also process all the messages. And for deletion you can add some retention policies there, or some cron jobs you can say, where you will be deleting messages after some time, right? So this is how a message stream works. So now what is actually Apache Kafka? So Apache Kafka is basically a distributed message stream. It's kind of a message stream platform, right? So it is not a queue, and it provides you many offerings. High throughput, it provides you durable retention, it provides you like retention policies for deletion of your messages, it provides you partitioned parallelism, and also replayable logs, like you can rewind or reprocess your data which is coming from the stream, right? So what are Kafka core components if we talk about? So these are some real world use cases, you can go through it. So Kafka core components and internals, if we talk about, Kafka has topics. So topics is basically a feed or log. A topic you can consider it like a table, or where your data will be stored or your messages will be stored. And what is a broker? A broker is basically a server that is hosting the partitions, and partition is basically like ordered sharding or shard for the parallelism. You can basically understanding like a way, like topic is a table, partitions are shards, brokers will be storing the data, and these ladders serve read and writes, right? So there are many other components as well in Kafka, so that will be like some advanced thing. But as of now we just need to focus on topic and consumers and producers, right? So now if you want more into like Kafka architecture, you can see. So this is kind of it can be work you can work with Kafka in a distributed manner as well, like you can create a Kafka cluster, and in cluster you can do the partitioning as well. Here in this architecture you can see we have a topic and we have some different partitions here, so each partition can work with different consumers, right? So we have some controllers as well. So what are controllers? It's nothing just for running the Kafka. So a Kafka cluster, if you talk about a Kafka cluster, it's kind of a coordinated group of server processes or brokers that will be managed by a controller layer. So there are two controllers here. One is Zookeeper, one is Kraft. So these both we usually use Zookeeper mostly. It is quite famous. So with Zookeeper we can run Kafka, and we will be doing the same in today demo. Okay. So this is architecture image as well here. If you want to go more deep dive into Kafka, you can refer this. So how you can install Kafka? This is a complete guide here for installing Kafka and starting the Zookeeper and Kafka. So if we just talk about a quick demo about like how you can create a topic. Now let's say I have installed Kafka in my machine, okay? So I'm running Zookeeper and Kafka both in my machine. Here I'm running Zookeeper and I'm running Kafka, and I've also created a sample or test topic. The topic name is Twitter stream, but I will be creating a new topic as well. So I will be just naming it like Kafka topics, and create topic. I will name it test topic, and the server, my server is running on 9092 port on my local host, right? In partitions I will be choosing one only, and replication factor also one. Okay, I think there's a typo. So we have created the test topic, right? So now what we can do is we just need to insert some data into this topic, right? We have created the topics. We can also list our topics here. So now you can see we have two topics here. One is test topic and one is Twitter stream. So how I can be a producer and I can send the messages to this topic, right? So how I can do, I just need to open the producer console, right? I will just open producer, and I will just say topic will be my test topic, and my server is, we know already, localhost 9092, right? That's it. So now I have a CLI or console kind of here, where I can post some messages. So let's say I will post a simple JSON format message. I'll just say user Tushar, and let's say nothing else, right? This is the only thing. Okay, that's it. So this is I have sent this message uh, to my Kafka topic, right? So how I can also like do or I can check my messages, like my messages are coming there or not. As here I have this producer console. In a new tab I will open the consumer console as well, like Kafka console consumer. Okay, I need to add my topic, test topic, and my server. Okay, and I will just say from beginning, because I need the messages from the beginning. So you can see the message is here, what the message I have sent to my topic, right? So now if I will send a new message as well, let's say I will just say data dummy, right? Here you can say my new message is here, right? So this is how you can work with Kafka, and this is just a CLI demo. And let's see how you can also use in actual, if you just want to get an idea like how it will be working in real life applications. So I'm just opening my VS Code here, and okay, and I will be opening the terminal. Here I will be creating a Node.js project, and I'm just initializing a simple Node.js project here. Now I will be installing the Kafka.js. So Kafka.js is nothing but just a Kafka client which is provided by Kafka for Node.js, and I will be creating two files here. One will be for producer and one will be for the consumer, right? So I will be creating producer.js, and here you know how we can import any library. So I will just say Kafka. I will import it from Kafka.js. Okay, I will just try to run it if it's working fine or not. It's working fine, no problem in that. Now I will just create a new Kafka client. I have a typo, it should be a capital letter. Okay, and new Kafka, and I will just say client ID p1 as partition 1 or something. Now for the brokers I need to provide the my server URL, so that I will provide as localhost 9092. That's it. Okay, that's it. Now I will be creating a producer here using kafka.producer. So this is a producer. Now I'll be starting a synchronous function, and I can just create like const send function. This will be a async function, and here we are saying producer dot connect to connect to the producer, then producer dot send. Here we need to add some details like the topic name. Topic name is test topic, right? And the messages, let's say these are the messages which we will be sending. So a message can be key name, value will be in JSON string, right? So I'll be just saying anything like user Tushar or something. uh, that's it. Okay, so these are the messages which I'm sending here. Now I will just say console.log message sent or not. Okay, and now after this, once message will be sent, I will just disconnect from my producer. Okay, send dot cache console dot error. That's it. Now I will just run this file. You can see to retain same partitions and all. Now you can see the log message sent, and if you want to see the message here, you can see user Tushar. This message has been sent from, but this message has been sent from my Node.js application, right? So here in the data, even if I change the user from my name to KubeKode, so and I will run the application again, so you can see uh, a new message is there, user KubeKode. So now we have a producer, but we need a consumer as well. So consumer will be basically consuming the messages, right? So I will just create a consumer.js file. Okay, here also similarly I just need to add the configs for Kafka. Now instead of producer I will create a consumer, right? And every consumer should have some consumer group. Okay, so consumer group is just basically a group of consumer to identify the consumers which will be polling the type of messages, some specific type of messages. And I will just create a function start. This will also be a sync function. Okay, so here also we will connect with consumer, and you know consumer needs to subscribe to the topic, and we will add some details. The topic name, test topic, and from beginning true. Now we just need to run a function, basically run function, and consumer dot run, and we will say each message, on each message you should show me the message. And how I can get that, I just need to run this callback here, and I will just say console.log, and I will just console log this message only. Okay, that's it. Now I just need to run this function start. I'm not adding any exception here. Producer I have run again. Okay, I just need to run the consumer.js. So now you can see I'm getting my messages here, but this is not actually the specific message, right? This is why this is happening, because this message has a lot of metadata as well, not only the message. So how can I get the main message? Need to add a string here. I'll just say message dot key value. Now I'll be getting the message and the message value here. So you can see I'm getting the messages here. You can see the test topic, message, consumer has joined the group. So this is kind of a console that is running. So now I will just send a new message from the producer. I will, in a new tab, I will run the producer.js, and here I can see my message is coming. So it's coming like name user KubeKode, right? So you can see like this, it is working. I can do like this as well. Okay, so for better view, now whenever I will run producer.js, you can see a new message is coming, right? So how this is working? Nothing but this is just a simple thing. Like we have a producer.js, right? Producer.js is your producer application, right? And your consumer is basically your consumer application, which is consuming your messages, and it is not directly uh, sending messages to consumers. Basically in between there's a Kafka stream, and that is a Kafka topic, right? This is a Kafka topic, and this is storing all the messages which are coming here, right? And then our consumer is basically consuming the messages. So this is how actually Kafka works, and this is like a simple demo. You can do that. So this is mostly it for Kafka and for today's video, and in some next videos we will be going more deep dive or doing some real world applications as well for using Kafka, and also we can discuss some different kind of message brokers like message queues and all. So yep, thank you everyone for watching.